Please.
Nasiru Adam, please mute yourself. Mute yourself. You can stop your video for now.
All right, good day, everyone. It's just 2 minutes to go. So for those people who might not be able to access the Zoom link now because the Zoom has just reached 100, we've created the YouTube link already to entertain for the exercises. So we will share it across all the group as well. So for those who are struggling to join, yeah. So we'll be live. The instructor will be live in 2 minutes time. Thank you.
Okay, everyone, good morning, good afternoon, good evening, good day. I don't know if I'm actually audible enough. Please let me know if I'm actually audible, please. I need to know if I'm audible.
Yes, you are audible, sir.
Okay, everyone.
Now
Good
we
morning,
are
good
ready.
afternoon, good evening, good day. Okay. I don't know if I'm
Someone
actually
said I'm
audible enough.
audible.
Please let me know if I'm actually audible. Think we can kick off, right? I need to know if I'm audible. Okay, I think let's start in the name of Jesus.
Yes, you are audible, sir.
Okay, once again, good afternoon, good evening, or good morning, good afternoon, anywhere you're actually watching
Now
from,
we are ready.
whether it is morning or evening. Greetings to you. So a quick one before we start.
Your sound is.
For
I
those of
think
us
your
on
sound
YouTube,
is
please
very
just
echo.
keep dropping comments. So let's start with a little talk. So how has been your learning experience? What are the challenges you are passing through? Oh, sorry, please hold on, guys. Let me just set one.
Hello, is this audible?
Sorry, please hold on. Let me try. I'm trying to sort something out here.
So you have to so you have to look them individually, not to look for
Michelle,
get
I
it's a one individually.
but can you speak now?
Done back already. Okay, sorry about that. So I think, am I good to go? I need someone to help me confirm if I'm good to go.
We are good to go.
Go ahead.
Sorry, can you hear me now, please? Am I audible?
Very audible.
Normal right now. So we are good to go.
Okay.
Yes, you are audible. But please,
Okay,
if
all
you are
right then,
not
all
the
right.
one speaking, you
So I was saying
can
something earlier.
mute your
Please, I
mic.
want to drop your comment about how your learning has been, what are the challenges you are passing through. So just drop a comment. I'll be on the lookout. I'll be checking both the YouTube and also from the Zoom here. So just drop a comment. What are the challenges? How has been your learning experience so far? And as I said, I believe that by now we should be done with both Module 1 and Module 2, meaning the introduction to GIS and this one that we're actually trying to overview at the moment, which is Module 2, the spatial data type and the coordinate system management. So so let me see your comment. Drop your comment. How has been the experience so far? Okay, someone said my learning challenge is that I can't access the second video, working with spatial data and coordinate system in GIS for module 2 because I can't do the assignment. Okay, that's not actually true. What else again? I will address that shortly. We still did not get the opportunity to be included in any of the WhatsApp group. Oh, really? By now? Uh, someone said, okay, hold on. About the WhatsApp, a link will be dropped. Just both Zoom, those people on the YouTube and on Zoom, a link will be dropped. So just be on the lookout for it. That is for people who are actually on what's it called? People who are actually who are still yet to join the WhatsApp platform. Good, sir. I'm unable to move on to the second module even after submitting the assignment. I can't access module 2 part 2. I'm very grateful. The way you teach is exceptional. I have already finished my assignment and uploaded. Thank you very much, Akulo, if I pronounce that right. My challenge, please, you should all please make sure that your mic and your camera is actually muted. Please, your mic and camera, make sure it is muted. The admin, please help me turn off any cameras or any mic that is not muted, please. Both cameras and just to avoid distraction, please. All right. So this person said the challenge is about the assignment. Are the assignment to be done, banned, submitted before or live training section? The second video, module 2, is not accessible. I went through the second module, but I was not able to see any second assignment. Okay, all right, no problem. Let me check YouTube here. Although I have submitted my assignment module, one assignment late and it has not been verified. My basic experience is missing out of the class. Most time my notification comes in late. Module 1 assignment is still pending. I can't access module 2. I cannot access the second part of module 2 assignment. So okay, I think everybody questions or experience is actually the same. So let me start this way. I believe you can still hear me, right? Please, just people at the Zoom, please drop a comment for me if you can still hear me. I just need a thumbs up or something like that to know if I am audible. Okay, all right. Thank you very much, Mr. Moses Michael. So, firstly, about the assignment. Now, if you are still seeing your assignment as pending, you are still seeing something like pending after you submit, be rest assured that you've submitted already. Just that at my own end here, I've not actually approved it yet. But that is not actually the reason why you are unable to access the module 2. So the assignment, either pending or approved, should not be a barricade of you actually going to the next module. So in as much as you are seeing pending in your assignment, be rest assured that you've already submitted. Very soon, I'm going to start approving everything. In fact, I've actually started approving some actually. But what I'm trying to say is that is not an hindrance, or that is not actually the main reason, or that is not a reason for you not accessing the second module. So please take note of that. So for those of you saying you've not been able to access module 2, your assignment is still saying pending, you cannot access module 2 because you've submitted the assignment. In as much as you are seeing there that your assignment is writing pending, you've submitted already. Very soon it will be approved, so you can actually move on to module 2. Now, concerning those of you that is actually unable, that you've not been able to access module 2, which is spatial data type, the coordinate system, and the data management. Now, here is actually the reason I see, or I'm able to, try to analyze what is actually going on. So that LMS you are using, the learning system management that you are currently on, it is designed in such a way that the course, all the whole course was live on the 10th of August, that is last week, Monday. It became live 10th of August. So remember that I said that each module is for 1 week, meaning that last week we did module 1, which is introduction to GIS. This week we are doing special data type, which that is what we do for throughout this week. Next week will be another module. So what happened is that, or what I did was that, if a week is not complete, please get me right, if a week is not complete, you will not have access to the second module. It does not even matter, maybe you finish module 1, let's assume maybe you are still in module 1, maybe you now finish the module 1 in just 1 day or 2 days. The second one will not open. It is designed in such a way that it is meant to count 6 to 7 days. So let's assume you register today. Please take note of this, because I will no longer, because my DM is even actually full concerning this particular issue. So I'm actually addressing what is going on. Now, as I said, for those of you who actually enrolled in the LMS on the 10th of August, by now, I believe that you should already have access to the, you should have access already to the module 2, because 7 days that is set is completed already. So for some of you who is still having issue accessing module 2, I believed that what happened is that most of you enrolled late. So peradventure, maybe most of you or some of you enrolled, maybe let's assume you enrolled on Friday. Remember that I said that the course went live on Monday. So peradventure, maybe some of you enrolled on Thursday, Friday, Wednesday. So from the date of your enrollment, the date of your enrollment, you count 7 days. If that 7 days is not complete, the module 2 will not be unlocked. I don't know if that is clear. Let me hear what people are saying. Some of us are not on the WhatsApp group will be dropped. Please, I need a comment concerning what I just explained now. Did you get what I actually explained? The major reason why some of you are unable to, why the module 2 is not actually unlocking for some of you, is because 7 days, which is actually set, is not actually is not complete yet. Your 7 days is not completed. So that means for some of you who actually enrolled late, so it means that you have to be patient until the 7 days is complete. Please, I don't know if that actually makes sense. But however, going henceforth, I've actually unlocked all other courses, all other ones from next week, from module 3 to module 4. Don't worry, it will not be unlocked again. It will be free for you to be able to access. The reason why that was actually put in place was actually to control your learning. It's actually to control your learning. I know that some of you are actually, you are very, I don't know, you want to finish all the whole course in just 1 day. So I deliberately created it that way, just to control the learning system, the learning structure. But henceforth, due to the fact that I can see that there's a lot of issues, there's a lot of up and down. So I've actually unlocked from module 3, module 4. I've unlocked it, so it's not going to be locked. You have access to it. So please take note of that. But for course 2 currently, if you still do not have access to the course, it means that the time for you to unlock is not yet. That is because you enrolled late. So assuming you enrolled when the course was launched, which is August 10, then I believe that you should already have access to module 2. Module 2 should be unlocked on its own. It will automatically unlock on its own. So once again, if you are passing through the challenge that your course 2, your module 2 is not yet accessible, just be patient. It will unlock. However, a link will be posted now. That link is to this is for some of you who are saying that you don't have, especially I think I can see another complaint saying that you don't have access to the video, that the second video is not actually playing. Now, a link will be tagged now that link is actually containing the source file itself of course 2. So you'll be seeing in that link, you'll be seeing the Google Drive link, you'll be seeing the what's it called now? The videos, the 2 videos and the course material and every resources that you need. I think the admin is going to help me both on Zoom and on on YouTube to help me send that Google Drive link. So for some of you maybe who did not have access to watch the second part of the video, use this Google Drive link so you can actually download all the videos and the resources. And by the way, in the LMS, you always see something like, let me see if I have access to it here. No, don't let me go there. I don't think I have access to it yet. Don't let me start out what I'm doing. So if you, for instance, if you go to maybe one video, you always see CTA, a call to action button, whereby course video. So you can also, in case maybe you are unable to watch the video directly from the LSM, just click on that course video. It will take you to the source video itself, to the Google Drive of the video itself. So you can also download or get that video there. So in this kind of case, I don't think there should be any excuse, or I don't think there should be any form of what's even the right words to use like this. Meaning that video, especially the course 2, you now have 3 access. 1 from the LSM. So let's assume you are unable to get it from the LSM page. There is a button that is actually there. Click on that button. It will take you to the Google Drive of where the video is. So you can also download the video from there. The third one again is a link will be dropped, which I believe it should be dropped by now. Yeah, it's dropped. For those of you on the YouTube, please, I think it is pinned. You will see Google Drive course 2 file. Please, that is the source of, that is when you get access to the source of course 2, both the videos and the course material and everything used in this course 2. So I believe that by now there should not be any, there should not be any dispute about course 2. I don't have access to this. I don't have access to this. Please, I can't see the link on Zoom. Please, someone at the back end of Zoom should also please put the link there. So I think that is actually settled. Is there any other one again? Is there any other issue concerning that again? Yes, we understand the explanation. Thank you very much. Fali, Mrs. or Miss or Mrs. Lawal. Thank you very much. I believe everybody should get my explanation by now. Let me check the YouTube. The second video is still not here. Can't you get, please, hey, what I'm saying is that, fine, you can, I understand the fact that you cannot access, maybe you are passing through one challenge whereby you cannot access the video, the second part of the video. Please make use of this link. Now, this link that is being tagged on the YouTube, make use of it. The video is there, so you can be able to download the video from there. And as I said, the reason why it was not unlocked, why it is locked, why you don't have access to it is because you enrolled late. So you just have to wait till the period that is actually assigned to that course 2, which is, I believe, which is 7 days after course 1. So you just have to wait before you can have access to. But so that you can able to catch up, the link has been pasted on the YouTube. Just go there and you will have access to it. I think I'm clear about that. I did module 1 on time and submitted the assignment of it because the percentage of what I haven't covered does not increase. Meanwhile, it's still 0%, even though I have done everything in time. In as much as you've completed course 1, it should always read. You should always see something like 80%. For those of you that has completed course 2, you should see something like 27%. So I don't really understand what you are saying. In as much as your course 1 is completed, you did the assignment, you did the video, you watched the video, it marks like it sticks for you, automatically it should it should read. It should be at 18%. Thank you very much. It is now clear. Thank you very much, Usman Empire. Only part 1 module 2 is available. The next button is gray out. I enrolled before August 10. All right, I've heard what you say. Please make use of the link, the Google Drive link that is actually sent, that is actually pasted on the YouTube at this moment. Make use of it. I've heard what you said. If you download the second video from the link, how do you submit the assignment? Okay, now concerning the assignment, yeah. Oh, I did not the course 2 assignments, which I believe that if you are talking about course 1, I don't think that anybody should have issue with course 1 at all. But at this time, course 1 assignment and the video, I don't believe that anybody should have issue with it. But concerning the course 2 assignment, so do it. I know that I've not actually included it in the LMS because there is some glitch at our back end there that we're still trying to resolve. So, but for now, do it. The link will be later be posted either from the LMS or it will be sent to the group. But just do it for now and do it for now. Keep it. So once the link is posted or once it is added to the LSM, you will have access to able to submit the assignment. As I said, the assignment should not is the assignment as important the assignment is. It is not supposed, it's not a factor for you to proceed to the next module. The assignment, don't get me wrong, the assignment is very essential for you to do because it will later count at the end of the course. But however, what I'm saying is that it should not be an hindrance. It is not an hindrance from you proceeding to the next module. The hindrance for you proceeding to the next module is actually because you enrolled late. That's actually the major reason that is causing the inaccessibility of the other module. I don't know if I've explained that right. You also need to click on the complete button of this course. Okay, is that all? Where is the link for the second part of the video? Please, I can't find the link, the admin SARS. I can't find the link on I'm only seeing the link on the YouTube. I can't find the link on the Zoom. For the sake of those who are on the Zoom, please, the admin. For those not being able to see the percentage process, they should scroll down and click complete. Thank you very much. If you know you are done with course 1 and it has ticket for you, just go down and click on that mark course. The mark has finished. I can't even recall what is there. I think it is so. You see something like mark has completed or something like that. Click on it. So automatically you see your percentage. Thank you very much, Miss or Mrs. Brigette Amonio. If the assignment contribute at the end of the course, can we have the marks for the assignment here? Oh no, I'm not marking, I'm not showing the mark, but don't worry, your assignment might be rejected and might be approved. For some of you, the assignment, especially in course 1, you just use ChatGPT and you know both the words of the chat of the AI you used, everything, just copied everything. You just copied everything and you pasted it there for me. Well, don't worry, very soon maybe I will start rejecting assignments. Well done. What else again? Yeah, I think that's all for now. So let's just move right into what we have because of sake of time. Because I already have 1 hour 30 minutes for this class already. Is there a preferred format for submitting an assignment? Of course, it can be in Word, it can be in PDF, in as much as it is document format. Anyone understood? Go ahead with today's lecture. Okay. So let's move ahead with today's lecture. So I actually wanted to even hear from you. For those of us that are done with course 2, I actually wanted to hear from you about what you guys have learned. But allowing some of you to unmute your mic, I felt like it might actually cause some distraction and all like that. So I think let me just move ahead from my side. So please, I'm not really going through over all the whole talk again. Please go back and watch the video for some of you that have not actually watched the video. So this is just more like an overview, please. Okay. So this week, we'll be learning, let me take this away. So this week, we started learning spatial data type and coordinate system and data management. So last week, we looked into GIS. If you can recall, we talked about what GIS actually means, the application of GIS. We talked about different terminologies, the component of GIS, and so on and so forth. I believe that last week, we also by now, I believed that everybody should have QGIS installed already. This is the second week of the course, the ending of the second week of the course. So I don't GIS. And if you have issue installing QGIS, I mean, The YouTube is even there for you to go and watch how to install QGIS. So I believe everybody should have QGIS on their system by now, because starting from next week, even from now, we'll be making use of the QGIS. So if you are still having any challenge, please send your screenshot to the group and tell us what you are passing through. But I believe by now, I mean, QGIS is very simple to install, so I don't think anybody should have issue with that. So in relationship of what we learned last week and in connection to what we are going to be learning this week, I mentioned that there are 5 components of GIS, starting from what? The hardware, the software, the people, the method, and the what's the other one again? The 5th one, I can't recall. But one of the things I think I said last week was the fact that as everything is actually important, the people, that one of the things that is also very important is actually the data. If you have your QGIS installed, you have your projects you want to work on, you have everything. If there is no data, there is nothing you can do. There is absolutely nothing you can do. What makes GIS is actually the data you have. And remember that with Divine GIS, that what makes GIS different from other analysis, like all these normal random analysis, data analysis, is just that we are analyzing a location-based data. So it means that there is something unique about the data we actually use in GIS. Take note of that. That the exercise why we are focusing much in this particular course too is data. Our major emphasis or focus is actually data. So for us to be able to take one whole week and look and study into this data, it should already give you an insight that there is, how would I put that? There is something very unique. There is something very, unique that you have to be able to understand and get in this particular data. So that is why we are looking into, in fact, this is even 3 different topics. I have to, combine these 3 different topics, even though they are even different. Sometimes when you go for, maybe, assuming this course is more elaborate and advanced, special data type alone can take over a week to try to learn coordinate system on its own, then data management on its own. But I try to compress these 3 together so that we can actually, so that it can actually make a lot of sense. Okay, so special data type and coordinate system. So we'll be looking into anytime we say data in GIS data or special data, what are we even trying to say? So look at this on your screen. I said difference between the regular data and the special data is that, remember I actually mentioned this in the last class. Special data attach an information to a location. Special data contains X and Y factor. I remember I said this very clearly the last class. That your data analysis data, that your data you want to collect on the field. What's the difference between those data and the data we will use in GIS is that, you see those data you collected, those data that you analyze, like the data analysis aspect, that data can also, we can also analyze those kind of data in GIS environment. Only that data, it's more useful, we can be able to make use of it when a location is connected to that data. So for instance, if you have, okay, look at the instance I use here. I said John lives in Lagos. That's the data. Am I right? I mean, that's an information. Information is a data, right? What I'm saying like this, you can form thousands of data from it. So one of the data we have here is John lives in Lagos. Now in GIS, when we come to geospatial world, that information, we cannot really do much with that information. Now it's more in the form of an attribute information. So what makes this John lives in Lagos more relevant in GIS space is actually the presence of something we call the X and Y factor. I don't know if that is clear. And what I mean by the X and Y factor is what we call the latitude and the longitude. It is always in figure. I believe that we should be familiar with Google Maps, something coordinate or something like that. You'll be seeing that will tell you that you are in so northern, so eastern. That is what we call coordinate. So immediately you impute this coordinate, this X and Y factor inside John lives in Lagos. Now the data is ready to be used in GIS environment. I don't know if that actually makes sense. Let me check. Second video of the module 2 is not available. Mr. Islamic, short for you. Please take time, sir. I've explained this over and over again. The link to that video has been pasted on the YouTube link. Please go ahead and download it from the link that is actually being posted. Thank you very much, sir. So I'm just trying to check my comment section if you guys actually understand what I just explained now. Please, if you understand my short explanation, just react to it, please, so that I can able to move forward. Okay, I believe I can go ahead. So I'm not seeing any comment. Oh, can I go ahead? I'm just trying to carry everybody along. I don't want to be that kind of teacher that, I just always want to see, know everybody is being carried along. All right, thank you very much, guys. So let's move to the next one. So when we talk about special data, there are three types of special data, not two, though sometimes maybe if you search online, you only see two, but technically we have three types of special data. We have something called the vector data, the raster data, and the attribute data. Please take note of this thing, because once we start moving deep into the analysis part, these are the terminologies, these are the things we'll be doing. These are what we'll be doing in the practical section. So please take note of the theory section. Fine, it can be boring, it can be, I don't know, it might not be pleased to you, but please take note of that, because once you get to the practical aspect, you might be confused. So that is why I'm taking my time to actually do the theory, then move into the practical. So I said again that we have the vector data type, the raster data type, and the attribute data type. So what is vector data type? Vector data type represents geographic feature using points, line, and polygon. It stores the exact location and shape of spatial feature using coordinates x, y. So basically, the whole English there is just that whenever you hear vector data, just know that it's talking about the shape of an attribute of a feature. The shape of a feature. Anywhere you hear vector data. Now, this is especially to those of us that we just started our GIS journey. Maybe we are not familiar with this. Anywhere you hear vector data, just know that what they are saying is that vector data is just a representation in form of shape of a feature. For instance, river is a feature. River is a feature. So when we say that we need the vector data of a river, what we are saying is that we want a shape. We want a shape, a digital shape of that river. And of course, I believe that shape is what? Is linear. Am I right? Is linear in future. Am I right about that? So anytime we say we need, for instance, we need the vector data of a river, what we are saying is that we want a representation of the linear feature of that particular river. So they are always in three types, the vector data. It is always in polygon, in points, and in line. Take note of that. Vector data, any other type you see in vector data, well, maybe you know any other one, but I have not actually come across any other one. There are always three, the point, the line, and the polygon. And one of the things now that you now need to be careful of is that each type that we are seeing here, you don't just use it anyhow. There is the right type for the right features. For instance, you cannot use polygon for road. It does not make sense. Does that make sense? I mean, sorry, this is not a physical class. What I'm saying, I don't know if you are getting it. Road is what? Is linear, right? Now, if you want to represent road in more like a digital form, in a shape format, does it make sense for us to use points? Does it make sense for us to use polygon? Road is linear. So in that kind of case, we use a linear feature, a linear shape to actually, to draw, to represent it. For instance, again, let's assume what other shape again? Let's assume, okay, we want to know the shape of a building. A building is a, what's it called? A building, for instance, a single building is a feature, assumed is a feature. So we now want to represent that building, the shape of that building, we want to represent it. In that kind of case, we can make use of polygon. Polygon comes to place because we need to digitize or trace out the roof. Let's assume maybe you are using, I don't know how to put this right. Let's assume maybe you are using maybe Google Map or something like that. You know, you saw your building, your house building in your house building or your building in a Google Map, something like that. And you are trying to know how does my house actually looks like. What you'll be seeing from above is actually the shape of the roof of your house, right? So how we can I able to represent that is actually to use polygon. Of course, I believe everybody know what polygon is now. Polygon, 5-side, is it 5-side or whatever side, but we just call it polygon, no matter how many sides it has or something like that. You know, you trace it out, you trace the roof out, that's what we call polygon. And point is just a single representation. Point is actually majorly talking about a single representation. So for instance, maybe you want to count the numbers of trees in an environment. You want to count the numbers of trees we have in an environment. What we use in that kind of case, or what is ideal to use in that kind of case, is to use points to label each tree. So tree 1 using point, tree 2 using point, tree 3 using point, and so on and so forth. I don't know if that actually makes sense. I'm just trying, please comment so that let me know if you guys are actually getting me.
It's making sense.
Yeah, thank you. Someone said super simple. Vector equals to shape, raster equals to pixel, attribute equals to information about them. Thank you very much for that. Thank you very much for that. Yeah, got it. Okay. So let me just move ahead then. So I've actually, I actually went ahead and explained what point actually means. I say point is just a simplest type of vector data used to represent a specific location on the map. It defines a single coordinate. Now, please take note of these words. Read in between the lines. Please take note of that. I said that it defines a single coordinate. Now, let me go back to this. Now, look at this shape you are seeing here. Look at this polygon shape you are seeing here. You can see all these points, all these like dots round. This is a polygon, this is a line, and this is a point. So you can see all these points. Now, you see all these points. We call it node. We call it points. But all these points you are seeing, they are actually combination of X and Y, of a location, of a coordinate. So this particular point you are seeing carries a coordinate. This particular point you are seeing carries a coordinate. This one carries a coordinate. This one carries a coordinate. This one carries a coordinate. So it is when we add these coordinates together, what I mean by add is that when we join all these coordinates together, that is what gives us polygon. Unlike a point is just one single coordinate. That's all. I don't know, maybe you understand. Someone is asking, can tree be presented by point vector data? Of course, that is what I just explained. The best idea or the best ideal to use to represent tree or to count tree is points. Just place point upon all those particular tree. That is the best representation. You can use polygon as well. Maybe a circle to actually draw, to draw the shape of the tree. You can also use that as well. So I don't know if that is, I don't know if you actually get that. Okay, let me go back. So I said characteristics of point feature include represent individual location, have no length or area. Take note of that. You cannot calculate area or length using points. It does not make sense. It is defined by what? Only one coordinate. Component of a point. I say, of course, coordinate, exact location, symbol, the visual marker used to represent the point on the map. So, you can use dots. You can use something like this location icon that you are seeing. You can use, what other thing again can you use? Different kind of representation that actually has to do with point. You can use them. Attribute information describing the point feature. Example attribute for hospital name. Okay, I think that should be an error. That should not be included there. That should not be included there yet. So let me just move ahead. So the second type again is actually line. I said line is a vector feature used to represent linear geographic feature, as I said. Think about any linear feature that we have. Road, river. What other linear feature do we have again? I can't even recall. Just think of them. In that kind of case, we cannot use points. We use line. And I said it is created by creating two or more points, vertical. Now, please don't get confused. And the reason why I'm actually going this basics is actually for the sake of the people who, who are not familiar with GIS. Now, remember that I said here that this polygon, that it is when we, bring together all these coordinates that later gives us this polygon. Now, in the case of line, is also the same thing. The only difference between line and polygon is that line is vertical now? Is straight. Sorry, what's the right word to use? Sorry, I don't want to confuse people. What I mean is that instead of polygon we form, polygon is closed. Polygon we closed. Of course, I don't know, maybe you get that. Polygon will definitely closed, but line will not close. Line will continue to be either zigzag or straight or something like that. It will not close. Please take note of that. Look at these images beside you. Look at this road. You see, there's not any closing point here. So that is line. Look at this river, this stream. Is this stream or river or wherever? You see, it is linear. It's not closing. The moment your line, the moment your vertex or whatever you're drawing actually connect or actually close, just know that what you've done is actually polygon. So I don't know if that is clear, but I believe it should be clear. Vertex, component of line, we have the nodes. Yeah, these are the nodes. This is what we call nodes. This single, let me go back again. This is what we call nodes. You see, every point, every angle, all these angles you are seeing, that is what we call nodes. Segment, straight paths connecting vertex, yeah. Characteristics contain multiple connected points. I explained that. Have a length but no area. So remember that our point, you cannot calculate area, you cannot calculate length. But in line, you can actually calculate a length of a particular place. So let's assume maybe you are working with a road. So it is easier for you to know the length of a road. It is easier for you to know the length of what's it called? The length of a river. It is easier to calculate, but you cannot calculate the area. Can represent a simple or complex path. So let me check the comment section again. Basically, there are three. Line. Is there any comment from here? Line is continuous. Thank you very much for that. Line is continuous. We can see your diagram on your explanation. We can't see the diagram on your explanation. You can't see my diagram. You can't see my screen. That means you can't see my screen. My screen is visible now. Polygon is closed geometric feature. Yeah, thank you for that as well. But for the sake of people who are just actually, starting GIS, let's reduce the grammar for them. Yeah, polygon, definitely. Polygon is a closed geometric features. So then here we come, polygon. So I said polygon is a, can't see this. Polygon is a vector feature used to represent area, region on the map. It is formed by 3 or more connected lines. Now, you can see the difference now. So, lines are not connected. So, immediately your lines begins to connect. It is what? Polygon. Polygon represents features that have both length and area. So, polygon gives you the access to be able to calculate your area, your length, and so on and so forth. Example include countries, states, land, forest, buildings, administrative boundary. I'll be showing you an example. If I look at this diagram beside this diagram, this China, these maps like this, you can see the way you were able to differentiate each country. That is what we call polygon. How you able to know that, okay, this is the boundary of so. This is where the boundary of China reach. This is the boundary of where so reach. That demarcation is boundary, is polygon. So we call it polygon. Because it is a type of a vector, what's it called? A vector data type. We can't hear you again, sir, since your audio is lost. Really? Hello, can you still hear me?
Yes, sir, we
Someone
can
said
hear
he
you.
can't hear me. Is
Yes,
it the
we can
only
hear
one?
you.
Is it from his end? Please, if you can hear me, just let me know. People can hear me. Please check your
Yes, we
audio,
can
Mr.
see you.
We can hear you clearly.
Afiza. Sorry if I didn't pronounce your name well. Please check your own audio. It should be from your hand. Someone said I'm audible. So component of polygon, we have vertex, boundaries, edges, and so on and so forth. Don't worry, maybe when we start making use of this data, you can be able to understand better. So the second data that we have, the second special data that we have, please don't get confused. How many type of special data do we have again? We have 3. Number 1, the vector data. Number 2, the raster data. And number 3, the attribute data. In vector data, we have 3 types, which is what? The line, the point, and the polygon. Then again, in raster, we have majorly 2. I mean, you see, raster can be a bit confusing sometimes, but let's just get into it. I say raster data is a type of spatial data used in GIS to represent a word as a grid of cells and pixel. I think someone mentioned that already, that raster equals to pixel. And I think I explained pixel to you in the last class, so I will not be going back to it again. I explained pixel, what pixel. That's why I was saying that you should take note of terminologies when we're looking into terminologies. Just a recap, that if you want to understand pixel better, look for an image on your phone, a screenshot image or something on your phone. Try to zoom in. You will discover that the more you are zooming in, the more you begin to see some box, something like box, looking more blurrish or something like that, something like this. That is a typical example of what pixel is. So in GIS, we also, in GIS, when it comes to GIS, it's not just blur, it's not just boxes again. It's now an information that actually represents some particular thing. So we don't just to us in GIS world is something important to us, is an information. Those particular boxes you are seeing, they carry some information that is actually very essential that we actually need. So I say each cell contains a value that represents an information, such as temperature, elevation, land cover. I think I will explain that later on. Structure of raster data. I say raster data is made up of rows and columns. If you look very well, look at this image beside it. You can see rows and columns, just like your Excel spreadsheet. Is that the right word? Is that the right word? Rows and columns. That's exactly how pixel is. How raster data is. Each cell has a specific value. I don't really want to go into the technicality of this value, this digital number. So I think I will just try to keep it simple. Vector raster attributing. Okay, thank you for the recap. Raster, a picture made of tiny squares. Okay, someone is trying to even give us another definition here. He said raster data, a picture made of tiny squares, just like a digital photo is made of pixel. Thank you very much. The raster map is made of a lot of little squares. Each square holds an information, its color, height, and temperature. Thank you very much for that recap. God bless you. So, I don't really want to go into the technicality, because if I start, say I'm explaining the technicality of raster, it might actually takes time. But this is how actually raster actually means. But just know that all those boxes you are seeing, they are representation of a future and of an information that is actually very important. So I said there are 2 types of raster. Well, I don't know, the internet might give you something else, but as far as I'm concerned, or as far as my knowledge is, there are majorly 2 types, the discrete and the continuous. The discrete raster represent, can you see this? I'm sorry. The discrete raster represent distinct separate categories or classes. Each cells in the raster belongs to one specific class, and value do not gradually change. Characteristics value represent categories or groups. Boundary between classes are clear and defined. Each cells belongs to one class. Example, land use map, soil map type, vegetation classification, administrative region. You cannot, maybe you might not really be able to comprehend this example, but as time goes on, you will be able to see better. But let me see if I can. So this is an example of discrete raster. Let me explain continuous and let me see if I can connect the two together for better explanation. Okay, let me talk about the continuous. Continuous raster data represent data that change gradually across space. The value in the cell can have many values within a range. Characteristics represent measurable quantities. Value changes smoothly across space, often collected from sensors or measurements. Examples are temperature distribution, elevation, rainfall, air pollution. So here is it. The difference between continuous and raster is, what familiar example can I use? Or who can help me out? I need very simple example to use, a very simple way to actually differentiate between this continuous and now temperature, for an instance. Is that a good example to use? There are some values that they are in a gradual, how will I put it like this? In fact, I think don't let me do too much. Look at this picture you are seeing in continuous. You will discover that, is this even a good example? What I'm saying is that it's not actually, this continuous and raster is not really something that is just for your knowledge sake. This is what I'm saying. Anytime you see an image that there is a gradual changes, there is a continuous changes in its view, just know that that is a continuous raster. Example is elevation. Elevation is continuous. Am I correct about that? Elevation is continuous. So what makes continuous different from discrete is that continuous, we have now reclassified it back. So for instance, let's assume, okay, let me use the normal data. Let's assume maybe in a class, we have age groups, like we have 10 years old, maybe there are 10 years old in a class. There are 5 students which their age is between, we have, I don't want to confuse myself. In a class, let's assume there are 10 students. 2 of them are 10 years. 5 of them are 30 years old. So and so. Now, one of the things you discover is that you can see that the age is actually going gradually from 10 years to 30 years to 50 years. That is what we call continuous. Now, in discrete, what we do in discrete is that we reclassify it and we put each age inside in a different group. So remember that I said that in that class we have like 10, we can have like maybe 3 students that are 10 years old. So what we do is that every 10 years old, though, if you are 10 years old in this particular class, so you have come to this side, we put them inside the group, inside the class. Oh, if you are 30 years old, if you are all 30 years old, come here, we put them inside the group, inside the class. If you are 50 years old, so we call them together, we put them. That is the difference between continuous and raster. Simple terminology or simple English is that discrete is classified, is reclassified, is the reclassification of a continuous. Does that make sense? I don't know if what I just said now makes sense, but that's actually the idea. Discrete is the reclassification of a continuous. Let me see what people are saying. Okay, someone said it does. The raster is the grid of a little. How the information is stored continuously, kind of information is stored. For example, imagine a map showing how hot it is outside. 1 square 7 degrees Fahrenheit, 71. Thank you. A continuous something. That is what continuous is. Look at this image that we have here. You could see that there is a clear difference between this particular continuous image that I showed here and here. You could see that this one, you can able to differentiate each class. Well, when we move to the classification aspect, in the practical aspect, I think you understand better. I need to move now. So please, if in case maybe you don't understand, please, you can just drop the question on the chat, or maybe at your own leisure time, you can actually make more research about all these things I'm actually saying. So the last one, which is actually the attribute data, which is actually what we know as the information behind the data. Now, for every data you download, now this attribute data is actually more similar to what we call metadata. Remember that we divide metadata, which I explained that metadata is just talking about the data of the data, the information of the data. That is just similar to attribute data. Attribute data is talking about what information does this raster or this poly or this vector data contains. So that's why sometimes when you search online and you ask how many type of GIS data or special data do we have, what you might see mostly, it might just be raster and vector data. They don't always include attribute data, and that is because attribute data is not really a data per se, but it just needs to be added so that you can be able to value the contribution, what it actually brings to the table for us. So for instance, if you get your vector data, let's assume you went to download your vector data. That vector data, that river data, that stream data, whatsoever data you download, there must be an information that describes that particular data you just downloaded. That is what we call the attribute data. Is that clear? Attribute data is a data attached to either vector or a raster, or a raster data. Either vector or a raster data that actually tells us, that actually informs us, that made us understand what that vector data is all about or what it contains. Now look at what you are seeing on your screen. Now this is a map of Nigeria. This is a polygon. This is a vector data. This particular map you are seeing, you can call it a vector, you can call it a polygon, any more you want to call it. So now, of course, a country is a combination of, of many states, many local government, or however you put it. So, So now, how will I know which state is this? This place that is showing blue. The question is, how will I know which country or which state is this? How will I know, okay, this particular state, what other things is in that state? That is where attributes comes in. So if you look at this other side, you will see that you see a table showing ID, state name, capital, population, area, square, all those information. So automatically what this one is telling us that this particular place that actually shows blue is saying that, oh, this is Lagos State, and the capital in it is Ikeja. It has a population of over 40 million, and the total area is about 3,000. So that is what we call attribute data. The information of what? Of a data. It can be a vector data, either point, line, or polygon, or it can even be a raster data. That is, I believe that is very simple to catch as well. Another example is elevation. A mountain does not suddenly change from 100 feet. Thank you very much. The continuous data, that is continuous data, and raster grid can store those changing heights. Thank you. Source of raster data include Asta. Okay, we are still going there. That should be in post 3. Discrete data is counted, continuous data is measured. Thank you very much for those information. Metadata is information about the data. Thank you very much for those contributing. Let me check here as well. Okay, so I can move ahead. So now, I believe that is clear about special data. See, special data, there's nothing really much to say about special data. There might be much, but that is just a summary about everything. So if they ask you outside that, especially some of you just coming into the geospatial world, oh, how many special data do you have, or what kind of data are you using? You should be able to know that, oh, this is what they are talking about. We have vector data, raster data. So in fact, with this little explanation that I've made, I've actually said, if I just bring any data to you, you should be able to tell me from the explanation that, oh, this is a raster data, this is a vector data, this is an attribute data, and so on and so forth. So that's all about special data. Now let's talk about something very important: the tools for getting this data. So we are talking about river data, we are talking about satellite imagery, we are talking about raster data. Some of you all those data, some of you have a bank of data in your system. You went from one platform to collect data, a lot of data. So I felt like one of the things we even need to look into is that all this data that we are making use of, or all this data that we are making use of, how did it get about? Like, how was it generated? I don't maybe understand, how was it even generated? How did we get it? Some of us, we just go and download data and start making use of it. We never ask ourselves that question, that how did they come about this data? So how they came about it, of course, still coming about it, is using some tools, using some means, using some platforms. So for instance, we have a physical survey. I believe that some of you might have participated in one survey or the other. If you are a graduate of a school, if you are a graduate, maybe in the course of your final year project or something like that, you have to do it. Your project has to do with something like sorry, hold on. What's this? Okay. Sorry about that. So maybe, it has to do with, now, some might actually go to the field to speak with those people involved in those projects one-on-one and, record that particular thing they are saying. You ask them questions, maybe through interview, through online means, you ask them, then you begin to jot them down. It's also a means where all this data actually comes in. For instance, the data I just showed you now, let's assume maybe you are working with the population data, for instance. Population data, you cannot be on your home and get population data. Like the population data that we are actually making use of, it didn't just come about. All those sites that we went to download those data from, they didn't just make it up in their head. Something was done. A sensor was done, for instance. It was through this sensor that they was able to collate all this information, all these numbers, and present it for us that we are actually now making use of. So this data actually get through physical survey, physical survey and all like that. I won't take much time on that. Number two, again, how we get this data is through GPS. GPS, known as Global Positioning System, is a tool that is used to collect spatial data. And one of the things that this GPS does is actually to help us collect coordinates. So let's assume you want to know the exact location, the X and Y coordinate of a particular place. All you just need to do is to carry this GPS, go to that particular location, that particular thing, with few clicks, it will give you your XYZ of that particular place, and you can be able to make use of it in your, in your GIS environment. And it has actually advanced. Initially it was majorly in a design, or like something like a tool that was designed, but now every phone has an embedded GPS in it. Every phone has an embedded GPS in it. So I don't think that should be something strange to us. And I don't also want to go into the technicality about how you can be able to know your location. Those are technical parts. I don't think I want to do that right now, because for that, your X and Y coordinate, that your longitude and latitude, for you to be able to know the exact location you are, there's actually some principle. There's actually some, what's the right word to use? Some, back-end technicalities that actually happen before you can be able to know. Like, I'm able to tell you that this is the exact coordinate of this particular thing. But that is not the goal here. So another platform again, or another thing we have again, is the satellite imagery. Yeah, satellites. I don't think satellites should be strange also to you. We have thousands of satellites, and one of the things you have to be able to take note is that satellites are built for different missions, different purpose. I don't know if that makes sense. Satellite imagery, any satellite imagery that you know about, or that I think that it is being launched, know that it is launched or produced or made in respect to its mission. So there are some satellites that its own mission or purpose of building is to monitor weather. There are some satellites, I think I explained this more better when we get to the next week course, remote sensing and GIS. There are some satellites that their own purpose is just to monitor the Earth's surface. There are some satellites designed that their own purpose is just to monitor disaster, all these like hurricane, and so forth. Yeah, thank you. GoTV, DSTV, all those things, they are satellite and so on and so forth. So In GIS, there are also satellites that helps us, all this raster data that we are talking about, their major source is actually not the major source. The only source is actually, sorry. Their major source is actually from satellites. No, we have a lot. Once we get to Module 3, remote sensing, I'll be explaining the type of satellites we have. We have Landsat, we have what's the name of this second satellite? This common set, this second, we have Sentinel data. That there are hundreds of them, if not even thousands of different kind of data. So those are another place where this data. But then the UAV, we call it unmanned area vehicle, commonly known as drone. I believe even though if maybe you've not seen drone before, but you've heard of drone. So drone is also one of the important tool or platform where we actually get this data from. Assumed, drone is just more like me. I call drone a mini satellite, which to me that's actually what it is. Drone is just more like a mini satellite. Satellites are launched thousands of kilometers away, but there are limitations to satellites. As I said, once we get to Module 3, which is next week class, I'll be explaining that better. But drone actually, remove all these obstacles and remove all these hindrances and limitations. So drone is more like a mini satellite where we can also get all this information, all this data we're actually using in GIS or remote sensing, or anyone you call it. So am I missing anything? There are Copernicus, Airbus, of course. Of course, drone, fixed wing, and of course, we have different kind of drone, but I don't want to go into that. So let's move into the second topic, which is geodata and data formats. And this is also one of the things. You see, I've been saying things like you have to take note of this, you have to know this. See, one thing, I think God really helped in the course of actually creating this course. I mean, God was able to help that I was able to zoom down to what is actually necessary, not just anything, because I've rechecked, go back to all these materials again, and I've seen that everything from A to Z is actually, someone just said, what about missile? Is missile a satellite? I don't know about that. I don't know about that. You guys can answer him. Someone is asking that is missile a satellite. I don't know about that. So everything about this course, from course 1 down to course 5, believe me, all informations are very important. That was why I was making an emphasis that last class that don't try to skip a class. Don't skip a class. Make sure don't skip the video. Some of you are trying to fast forward the video. Is it that, well, my voice might not be pleasing, but at the same time, I don't see the reason why you should be fast forwarding the video. I mean, what if there are important information in that particular video, that you're in that particular place that you're trying to skip? So I don't see the reason why you should be skipping a video, especially if you've not even watched it before. So that aside that, so we are moving into the next topic, which is geodatabase and data formats. And this is also an important topic. So I said geodatabase is a way to store, organize, and manage geographical data or special data into a computer system. So how can I explain this? In your computer system, we have folder, right? We have files, right? And the essence of we creating a folder is to build file into it. Your file can be any kind of thing, maybe picture or something, anything inside the folder. That's the essence of why we create folder. We create folder in a sense that we want, like, unlike me, that I don't usually like my desktop to be scattered with files. So I always create a folder for something and input all of those files inside it and so on and so forth. So I want you to see a geodatabase like that. So the idea is that all this data we are talking about, vector data, raster data, and so on and so forth, they comes in different formats. Please take note. Please try to follow along with me. Please just follow along with me. All this data, once we get to Module 3, which is next week class, that is when we start, moving deep, where we'll be practicalizing things together. And mind you, please, for the next class, which is happening next week, Friday, please get your internet ready, get your internet connection ready. Though maybe once the course actually open, you can actually have, I believe some of you will have practiced it actually, but what I'm trying to say is that in that module 3, you will be downloading some data for yourself. I mean, so you need your internet connection, you need your laptop to be ready, you need your QGIS to be ready. Please take note of that. So what am I saying? So what am I saying? I forgot what I'm saying. So I was trying to explain. So okay, now I was saying that the all this data we use. For instance, you want to download raster data. We are trying to download vector raster data because we are going to make use of everything. All those data, they have different formats. They all come with different formats. Take note of that. So that our GIS environment will not be scattered. So that we can be able to know what is what and what is not. That is where the idea of geodatabase comes in this sense. Geodatabase is an elaborate topic, but I'm just trying to zoom down. So think of a geodatabase like this particular cabinet you are seeing, where you put things in orderliness. Vector, you put vector in its place, you put raster data in its place, you put so in its place. It's just for you to be well organized. It's just for you to be able to know which is which and which is not. I don't know if that actually makes sense. Geodatabase stores different types of spatial data like points, schools, line, road, polygons, paths. So it is geodatabase that helps you structure all this particular format, all this particular type of spatial data, and put it in its place. It also stores attribute data, which is an extra information about those features like school names, road lengths, and so on and so forth. I explained that. Geodatabase helps keep data organized. So you can easily search, edit, and analyze it. It gives you that flexibility. It gives you that, I don't even know how to put it very well. It gives you that flexibility. It gives you that accessibility, accessibility to edit, to know what to do, to know where to go. They allow multiple users to work together in the same data without losing information. So that is one of the advantage of, for some of you, working in as a tech or something like that. I believe that you should know more about database now. One of the advantages is that as I'm here currently, maybe someone is in Pakistan watching, maybe someone is in the United States watching, we can have access to the same database. So in as much as you can be able to create a database, you can have access to it at your end. I can have access to it at your end without, one thing interfering with each other. So that's one of the importance of geodatabase. I say it can store large amount of data, including maps, area, satellite, and so on and so forth. So that's just the idea of geodatabase. As I said, it's an elaborate topic, but I don't want to go deep into it. But I can assure that the information I'm actually giving you is actually enough for you to, to comprehend and to know. Oh, time is going. So, type of data, special data format. Don't get confused. What we looked at first was type of special data type. But now we are now looking at type of special data format. This one is now format. What did I mean by format? If you snap a picture with your phone, you always see something like .jpeg, .jpg. Am I right about that? You always see something like .png. Those are what we call formats, and the extension. No, is that an extension? Maybe an extension format. I don't really know. But those are what we are trying to refer to as formats. So what the idea here is just that. It's just to bring to your consciousness that in the GIS environment, there are some formats that we use. There are specific formats that we make use of. So don't go and say, for instance, maybe I'm giving a data and you're seeing something like .cf. Don't go and say, no, is this data usable, blah, 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 and so on and so forth. There are some 5 formats that if you try to upload inside GIS environment, you will get error. So that's just the whole idea and concept about this. It gives you an orientation that if you are trying to download your data, you already know the kind of data format you are trying to download. That's just the idea. Does that make sense? Thank you, sir, for your presentation. Thank you also, sir, for listening. Wi-Fi, yeah, file name extension. Yeah, thank you very much, Mr. Fortune. So, number one, we have SHP. And definitely, we are going to be using .shp. So, anytime you hear something like, so go and bring in your shape file. Anytime you are hearing, go and bring your, just know that for you to be able to identify, so, what's the right way to put this? When you hear something like, oh yeah, import your shape file, what you are looking for, just know that it has to end with .shp. And this is one of the things, is this the right time to actually explain this? Okay, no, let me just leave that for now. I said this is one of the most common vector data formats. It stores points, line, polygon, and long attributes data. Shapefiles are widely supported most GIS softwares and are used in mapping. So in our GIS data type, we say we have vector, raster, and so. Just know that any vector data type, which is what? Let me know if you guys can get it, which is what? Road, I say road. Point, line, and polygon. Just know that all those type of vector data, they are called shapefile. And they always end with .shp. Though, when you download a shapefile, it actually comes, it does not come in just one file. It's actually a combination of different files. What other example can I use? I'm looking for a common example that is common around us I can use. Well, I'm not thinking of anyone for now, but what I'm just trying to say is that anytime you download a vector data, it always ends with SHP. So if you are trying to import your shapefile from where you saved it to your GIS environment, what you'll be looking for is .shp. So immediately you see that .shp at the back, just know that is a shapefile. We also have something called TIFF file. TIFF. Sometimes it can be TIF, while sometimes it can be TIFF. Take note of that. It's still the same thing. And this data this format or this extension actually comes with the raster data. So take note of it. Vector data type comes with what? SHP. While raster comes with what? JOTIF or .TIF or TIFF. Number 3, we have GeoPackage. GeoPackage, a modern versatile GIS format designed to store spatial and attribute data in a single file. So the essence of a GeoPackage is that, just like the word implies, is a package. I mean, inside the package, just think of maybe they came to deliver a package for you. Inside that package, there can be a lot of things. Let's assume you order something. Oh, I call your dispatch rider or whatsoever, sir, where is my package coming from? Inside that package, you can have the various items, right? You can have maybe your clothes, your shoes inside that package. That is what this package is also saying. Just that just like GeoPackage is, it only stores your geo information or your GIS data. So it has the ability to accommodate both shapefile and TIFF file inside just one single file. So it is when you now bring it to your GIS environment that you can now begin to separate it and begin to extract the one you want. We also have geodatabase format, which usually comes with .gdb. More unlike the GeoPackage, is a database format that can store large amounts of a spatial data attributes in one organized system. Yeah, it's just like a system. I mean, in that system, you can have different categories inside it. So that is what geodatabase is. The next one, GeoSyn. I don't even know the right pronunciation of this. Maybe it's GeoSyn or JSON. I'm not even sure maybe I've ever pronounced this well. But I usually just call it GeoSyn anytime I say it. GeoSyn. I don't know if I'm correct. Please, if I'm wrong, please correct me. So what's GeoSyn? GeoSyn is a vector format that stores geographical features using a text-based structure. For some of you who are actually into coding, most especially Python, you should be familiar with GeoSyn format. It's ideal for web mapping and sharing spatial data online. Yeah, if you want to share something online, this is actually one of the packages that you might want to consider. We have KML, short code for keyhole markup language. It's a vector format that is mainly used with application with Google Earth. It stores geographical point, line, and polygon. Note that KML is also an extension of a vector data type. Where it's actually mostly useful, it is when it is GeoJSON. Oh, GeoJSON. Okay, thank you. GeoJSON. I've been corrected. GeoJSON. Thank you for that. That's funny, kind of. So the only time KML is actually useful is when you have your area, your polygon, your area, and you now want to view that particular, you want to know that where that particular boundary actually falls, you want to know the area, you want to see what is inside that area, then you save that particular boundary as KML, then you take it into your Google Earth Pro. Then once you impute it there, it automatically goes to the location of that particular boundary that you create. Don't let me actually go far. Maybe as time goes on, we'll look into that. Of course, we have JPEG. Yeah, GIS can actually accept JPEG. The only thing is just that, should I even explain this? Your JPEG, your phone cam, your anything that is with JPEG, yeah, you can bring it into GIS. Just that, unlike all these other formats that I've mentioned, all those formats, they are, what's the right word to use? They are automatically georeferenced. They contain coordinates. I don't know if that is. They are automatically. So, for instance, if you save something as C format or KML format or something like that, once you impute it inside a GIS environment, automatically it will find its route to the exact location that it is upon the Earth surface. Unlike when you now bring in JPEG is not referenced at all. Maybe the only time you want to use JPEG format is maybe you are trying to digitize or you are trying to georeference it or something like that. That's when JPEG actually makes sense. So we also have CSV. Now, CSV is more like an attribute data. Now, CSV is only useful when it's connected to a shapefile. Does that make sense like this? A CSV file cannot be displayed in a, what's it called? It cannot be displayed in a GIS environment. It cannot be displayed on a GIS environment. That your Excel format, it cannot be displayed on, when you bring it cannot be displayed. It can only, remember that I said, it's an attribute. And remember our definition of attributes. Attribute is not really something that displays, it's just an information. It just contains an information. So the only time when it is useful, it is that when we now attach a location, something to it, then we can now start viewing this. There's one particular analysis in, I believe that should be Module 4 or Course 4. That is when we will make use of a CSV format in that particular period where we'll be connecting our CSV format into our GIS environment. So I think you understand better. So the last topic before I just show you some things and we call it a day. So the big problem, the coordinate system. You know, I can actually spend hours explaining this. That's for you to know the magnitude or the capacity of what this thing is actually weighing or what is actually carrying. I can go on and on to start, what's it called? To start explaining this. CSV file can be converted to topo, yeah, to topo map, of course. But please don't let me go into that. Maybe it is when we now start practicalizing that I think that can actually make sense. So the coordinate system in GIS. Now, you remember that this topic, this subtopic now, I said the big problem. I never said coordinate system. I deliberately put it there that the big problem. So meaning that is a problem. As simple as coordinate system is a problem. And please take note of this, because as you're aspiring to be this GIS professional, GIS specialist, GIS expert, and so on and so forth. See, a mistake in your coordinate system can spoil your whole analysis. Yeah. I mean, if there are GIS gurus in the house, they can help me testify to that. Let me see a comment on GIS on that. Let me see a comment on what I just said now. Anyway, let me just move ahead. What I'm saying is that coordinate system is very, very essential. I said the GIS coordinate system is how we describe the location of a feature on the Earth surface using numbers, usually in form of latitude and longitude. So how you able to know that you are in Lagos? How you able to know that? How you able to know that you are in? How you able to know that you are in? That your coordinate is saying 6 degree north, so degree eastern, blah blah blah. How accurate that is actually based on a system we call coordinate system. So I said why it seems simple, as I said, coordinate system are one of the biggest challenge in GIS, and it is often called the big problem. Well, in case you've not seen it before, this is the first time I was the one that actually come up with that. But to me, because I know that, it can be very, very tough sometimes when you are dealing with the coordinate system. Please, can you add the recorded video? No, that's not what I want to see. Okay, let me just go ahead. Now, why is coordinate system a problem? I know that you are trying to understand why it's actually a problem. Let me explain that briefly. It's a problem because we're being told that, I remember in secondary school then, they will tell us that I think they first came up with the idea that the Earth surface is circle. Some said no, that the Earth surface is round. Some said the Earth surface is oval. What's that shape? Some said the Earth surface look like an egg shape, whatsoever they call it. The major idea is that the Earth surface is not flat. It is circle. Now, in our analysis, the map we are trying to create, it is flat. We have to present it flat. So meaning that circle, that word that it is round, we need to translate it from being round to being flat, and that is where the issue comes in. So how do you, for instance, let's assume, look at this circle, this 3D you are seeing. So let's assume maybe I want to measure maybe from here to here in the circle format, why it is being circled. Now, definitely, the measurement I will get in that kind of case will be totally different from the measurement I will get when I try to spread the word in a flat surface. So this particular circle you are seeing, so let's assume now that I want to stretch it to flat. What do you think will happen? I need someone to give me an answer to that. The Earth surface is circle, the Earth surface is round, right? So now, but I need to convert it because I'm working with 2D. My map has to be in 2D. So meaning that this circle, I need to flatten it. So immediately I flatten something that is round. What do you think will happen? Give me an idea of what you think it will happen. I want a comment as soon as possible, sir. I need someone to just comment on that. I need someone to comment on that. I'm not seeing any comments. Okay, good. This was even the word I'm looking for. Someone said distortion is going to happen. Definitely, there will be a lot of changes. I cannot even start mentioning it. Okay, I even stated it here. I said the problem arises because the Earth surface is round, but our maps are flat. To represent a curved surface into a flat map, GIS needs something we call a map projection, which are ways of stretching or flattening the Earth. Each projection distorts the Earth in some of the way by either changing the shape, of course, distance, area, and direction. So you cannot tell me that something that is circle, you are not trying to make it flat. There will always be a distortion that will happen. And immediately there is a distortion, there cannot be accuracy again. So for instance, if I'm trying to know my exact location using the 3D, using the normal, projected normal circle, the 3D, I'm trying to know my location. That particular coordinate will be different when the Earth is not being flat. And that is where the problem actually occurs. Why is this very essential? It is essential because especially if they are working with a project that has to do with the location base, that has to do with you connecting it to real world, there will always be problem if you don't get the right coordinate, the right exact coordinate. So for instance, now this is a very clear example. Now, how did your dispatch rider, that person, that your logistic that is coming to deliver your goods to your doorstep, how is he able to know your exact house? Go, 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 go. How is he able to know that, oh no, this is the exact particular? It is through coordinate. But I'm not telling you that if there is not a system called coordinate system, if he is actually following maybe a 3D when it's still in 3D, he will not be able to get the exact location. So what makes you get the exact location? What makes you know that this place that I'm currently sitting? What makes you know that how the GPS was able to tell you so exact location that you are in relationship with either satellite or anything that, like, in relationship to that satellite that gives you the information, and in connection to where you're actually standing is actually what we call the coordinate system. So there are some people that has now actually took their time to generate something we called coordinate system. So what they did is that, let me see if I included it here. I said coordinate problem often appears when combining different data sets. Okay, now this is also the second reason. I've actually mentioned the first reason, that there will be an accuracy issue if your coordinate system is not actually right. And I said another thing here, that the major reason now, again, especially in GIS analysis, why it is very important is that all this your data set that you'll be downloading as time goes on from henceforth. You went to download a roadmap from one particular place, you went to download population data from another place, you went to download. Note that all those data sets comes with different coordinate system. So immediately you bring it into your GIS environment, there will be something we call displacement. I don't know if I'm doing a good job with this explanation, because I really need you to get this idea of this coordinate system. I'm just trying to check comments, please. So yeah, someone is saying, how are those distortion fixed? Yeah, I think I will explain that shortly. Okay, I don't think I'm seeing any comment here. So I believe that you are still following me, right? Let me just go ahead. So what I'm saying is that, what I'm not trying to say is that, so all those data sets you went to download, there will be something called displacement. Displacement is that where that particular feature is supposed to register, how we supposed to connect. You know that the whole idea of GIS is that we are connecting it to what is happening on the Earth surface in the exact location. So let's assume that I want to, I think maybe if time permits, maybe I'll try to demonstrate this thing. Let me see the time. Oh, time has gone. Let's assume maybe now, this building that I am currently, it is sited on a permanent location upon the Earth surface. So it means that there is a coordinate that is supposed to be attached to this particular place. There is a road that passes through the front of this place that I'm actually staying. Please just flow with my example. There's a road that passes through. So I want to be able to digitize this too. So for instance, if I use a separate coordinate, if I pick this particular location, this particular building with a separate coordinate, and I now want to download or get the road data using a different coordinate that is different from the house. This is just the simple best way that I can actually think that I can actually explain this. So those are already two separate coordinates. If I bring them into GIS environments, what will happen is that the two are you know that normally the two are supposed to be together. So let's assume this is my house and this is the road. So once you bring it into your GIS environment, they were supposed to still be like this. But if you are using separate coordinates, your house might be here, while that road might be here. Distortion, displacement. I don't know if that actually makes sense. That is just the concept about this particular coordinate system. Let me see if there's something. I said if your data is in different datum or projection, it may not align correctly on the map, causing errors in your analysis and all. So someone was now asking me that, Someone was asking that how are these distortion actually fixed? How did they fix about it? Well, I don't want to go into the technicality and so on and so forth, but the summary is that should I say they come up, or should I say they come up? Is that the right word? Let me just say they come up with two coordinate system, two type of coordinate system called the projected coordinate system and the geographical coordinate system. Just two type. Projected coordinate system and the geographical coordinate system. A projected coordinate system is the I'm seeing, hold on. I'm just trying to make sure I'm not making a mistake. Now, a geographical coordinate system, am I right about this? I think I'm right, yeah. A geographical coordinate system is just the coordinate system or the coordinates taken when the Earth or when the, sorry about that. When the Earth is still in form, is still in shape. While the projected, it is when they've actually flattened it. So there is a coordinate that works with when the Earth is flat, and there is a coordinate that works when the Earth is still in its shape. So when the Earth is still in shape, that is what we call the geographical coordinate system. While when the Earth is actually what's it called flat, there is actually a coordinate that has been developed out. That is what we call the projected. I don't know if that actually makes sense. I said the geographic coordinate system used a 3D dimensional spherical surface to define its location, meaning that okay, I think that will make sense later on. Locations are expressed in latitude and longitude, measured in degree. So now, here is not the catch about the two. Here is the catch. Can be asked that what's the difference now between the two? A clear example is that anytime you are using a geographical coordinate system, it is always in degree. It is always in degree. So it means that if you want something in meters, if you want to calculate something in meters, what does that automatically tell you? That you cannot use what? A geographical coordinate. Simple as ABC. Good. That is what I just want to hear. Someone said well understood. And I believe this is actually the same statement I believe I should be hearing from everybody. That if you are trying to, it's just a card, it's just one card. If you are trying to calculate something in meter, you want to know the meter, what is the meter of so, it automatically gives you the sense of consciousness that for me to be able to get a measurement in meter, I cannot use what? Geographical coordinate system. Why? Because geographical coordinate system is still in 3D, and 3D only measures in degrees. Simple as ABC. I say purpose, pinpointing exact location globally. One, it cannot be used for accurate distance or area measurements. Why? Due to the curve. I mean, it does not make sense trying to know the length of one particular place to another when it's still round. It does not really make sense, especially we that we are producing our map in 2D. I don't know if that actually makes sense. So please take note. I'm not saying that maybe one is wrong and one is right. I'm not saying the two. There are cases where you will need the two. The whole thing I'm trying to say, the whole point I'm trying to say, here is the whole conclusion of the matters. Here is the whole conclusion, the whole summary is that if you begin your project with projected coordinate system, make sure that all through your project, all the data you are bringing in is also in projected. If you started your project with geographical coordinate system, make sure that the rest of the data you are bringing in or what you'll be doing is also in what? Projected. So the moment you start having one data projected, one data geographical, there will be a displacement. There will not be an alignment. That's basically what I'm saying. Am I free? Am I clear? Does that make sense? Did I make any mistake? Did you guys go in the house? Please, am I especially for those of us who are familiar with this, please, did I make any mistake? Please, I'm also open to learn. Of course, someone said, is there a possibility of conversion from one unit to other accommodating this? Of course, GIS gives you the liberty to project, to change from one coordinate to another. Yeah, GIS actually does that. So you can easily change from one coordinate to another. GIS gives you that liberty. Okay, so I think I'm good to go. No mistakes, sir. Okay, thank you very much for that. So see, this is just grammar. See, basically what I'm saying here is that, wait, let me read first. Datum, the earth isn't perfect round, which I've actually explained. It's budget, it's boggled, a datum divine, which mathematical model. This is just the, what's it called? This is just the mathematical expression or the technical behind it. But don't let me actually really go deep. But this is what I'm actually saying here. That I'm coming, okay. I was just trying to explain this EPSG. I think the best way to even explain this is to show you. Instead of typing long, complex mathematical name, we use standard serial number to ensure GIS software understand exactly what we say. So here is what I'm saying. There's something we call datum. So, and I try to explain it here that the earth isn't perfectly round. The datum defines which mathematical model of the earth shape we are referring to. For instance, WGS. This WGS 84 in global standard is an historical Nigerian datum. I don't know how to actually explain. Not that I don't have to explain, but I don't really want to move into the technicality part. EPSG code, instead of typing long, blah, 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 global. So basically, this is what I'm trying to say. Now, one of the things that you have to note is that these people that come up with this, this geographical, this coordinate system of a thing, what's even the best way to explain this? Have you asked yourself, why is it that, okay, good. I think let me start from here. I'm just trying to explain what I'm saying here. Of course, as we are currently together, there are some people in different time zones. We are all operating in different time zones. For I currently here, this is already night. For some people, it might be afternoon. Some people might be morning. Some people might be, different time zone. Have you asked yourself that why this? I don't know. Have you actually that why are this? That is because that every country is actually sitting on a different, what's the right word now? They are sitting on a different location, different datum. I don't know how to put this very well. So that is to tell you that each country or different place actually operates with different, there is a specific coordinate or projected that they all use. Here is what I'm saying. Don't get confused. I stay in Nigeria at the moment. What I'm saying is that in Nigeria, there is a specific projected or geographical coordinate system that we make use of. Most of the time, we make use of something we call WGS 84, or we make use of, if it is projected, we make use of MINA, UTM zone, something like that. I don't really want to go into the deep details of all those things. But what I'm saying is that now, I stay in Nigeria that I'm making use of WGS 84. If you are in India, for an instance, India does not use the same coordinate system. There is a coordinate system that is assigned to that particular location. That is why it's very essential for you to know the coordinate system that your location is actually using. Does that make sense? Sorry, I need comment. I need to know if you guys are okay. Someone said makes sense. Yeah. So Nigeria, if you that are staying in Russia, or you are staying, I don't know the country you are saying, verify that am I using the same coordinate system? Like what coordinate system am I using? For some, yours can be WGS 24. Yours can be a lot of different coordinate system. I don't know if you guys get that. Please, I think this is actually how far I can actually go. I don't want to make this thing more complex. So that's just the whole idea about coordinate system. So the reason why I'm just trying to make emphasis on this is that, as I said earlier, if you use the wrong coordinate system, especially if you are doing something related to precision, maybe precision engineering, you are doing something related to precision, anything that has to do with accuracy and precision, coordinate is one of the things you might want to take note of. In fact, for instance, if you are into survey, I think those of you into surveying, you should know this better. And I really have issue with surveyors, actually. But don't worry, I'm not telling you my issue with surveyors. I mean, especially if they are making this their plan, and we are not trying to import it to, I'm trying to maybe create the shapefile in GIS environment. I mean, some do not even know what I mean, I still battle with this kind of issue where, I mean, I was seeing two different coordinate system that was used to, make the boundary. At the end of the day, the thing was not registering. It was supposed to be registering on a particular place, but it was not registering. So I knew that this is actually from coordinate system issue. I knew that this was coordinate system issue. So please, I'm just saying that be conscious of your coordinate system that you'll be using. If maybe your road data is geographical, make sure that if you are bringing river, if you are bringing building, make sure it is also in geographical. If something is in projected, note that all my res data should be in projected just for alignment's sake. Do you get the point now? Okay, someone said Ghana is using WGS zone 30 knots. Okay, thank you for that information. Layers with different reference type will end up giving rough presentation. God bless you, Mr. Mohammed Ali. Simple as ABC. Layers with different reference type will end up giving you what's wrong presentation. Thank you. God bless you. So yeah, please do your assignment. As I said, very soon I will upload the assignment into what's it called? Into the LMS, or maybe I will send a link where you guys will upload it. So please, there's assignment. Assuming I just don't want this thing to be chaos, I could have actually, asked us to, do this as a classwork set. All these are just questions, are just practical questions that we can actually, talk about to be able to know if you guys actually understand what I've actually been saying since morning. I said something. Look at this question too. A claim has been made that attribute data are not needed in GIS analysis. You use support. The essence of this assignment, especially this one, is just to comprehend, to know the level of your comprehension in what we've actually done. So let's move. Let me just show you one or two things, more like a practical aspect, and we can call it a day. So yeah, before going into the practical aspect, please, I discovered that I don't know, okay, let me just go straight. I mean, I think one of the things that, since we are not family, I believe so. We are actually not family. We are part of Precision Field Academy. So I believe that one of the things that you can actually give back to us is actually to follow our page, I think I stated that the last class. We have the Instagram page, the YouTube page. Some of you currently like this, you are watching on YouTube and you cannot just click the follow button. You cannot click. I mean, these are the things I felt like it does not reduce your data. It does not, it's something you can just do within seconds. So please, I think the admin are going to drop what's it called? They are going to tag our social media page. They are going to tag our social media page. Kindly follow. There are always some courses, some important information will always also drop on those particular page that might be beneficial to you. But if you are not following us, how will you be able to know? So please, the admin, kindly tag or pin our social media page. For those of you on the YouTube at the moment, you just kindly click on the like, click on the follow, click on the subscribe button at the moment. Please, I will appreciate if you can actually do that at the moment, like this, before we move into the practical section. Please, Mr. Kenneth, add me to the WhatsApp group. Please go back. The link has already been dropped. So just scroll up in the chat. You will see the WhatsApp link. It has been dropped already. The admin, sorry, please, I can't still find the social media. Is it there already? Yeah, okay, it's pinned already. You see the Instagram page is there. And also the Facebook is not posted, but please do well now, just within a minute, and kindly follow us on Instagram and on YouTube, please. Just do that, please. I would really appreciate you doing that now. Okay, so let me just show you a few things of what I've been saying, what I've been talking about since morning. Uh, okay. So I'm coming.
Sasa umeanza kuniona sasa ndio unaanza kuniambia mavitu zako. Hata mimi niko na plans baby. Hey, tell me class.
Okay. So okay. So a recap again. I said we started with special data type, and I said that we have yeah, I'm not sure if first we might be asking that how will you be able to do this? I'm not even sure if I'm not really sure if I put the data, but this is just a demonstration. By next class, which is the remote sensing class, don't worry, you already have your own data, you already start practicalizing on your own. So maybe in case if I do not put, this is just a demonstration. It's just a demonstration. You don't really just watch. You don't really have to, have your own at your end. This is just a demonstration. So just watch. So recap again, I said that we have three types of data, social data, the vector raster, and the attributes. So let me show you one by one. The vector data, I said we have what? We have the polygon line and what's it called? And the point. So here is it like this. Let me switch this off. So look at this thing you're seeing like this. This is a location of, this is a point. This is an example of point. Remember that I said that you can actually represent your point. So I can decide to change this point. This star you're seeing is just a marker. So I can decide to change it to another what's it called? Another marker. So let's assume I want to use, let me see this thing here, and let me change it to, you see, I've changed it to this, what's it called? So this is a point. This is how point looks like. Point is just one dot. I mean, one dot. So it's a representation of something. So for this case like this, let me see what I was actually using this to represent. Let me bring out my Google map. I don't know what this point is actually for, but I'm just trying to, point out that this particular point is representing one particular thing. So this is how point actually looks like. It can be in form of any marker. You can use pin, you can use that location icon, you can use anything. So let me try to open the attribute table of this. Let me see if there's anything in the attribute table. Okay, so now I just opened the attribute. Don't worry about what I'm doing or how I'm doing this. By next class, we'll enter into the full practical aspect of it. So I just opened the attribute table of this particular location, and you can see that it actually looks like. Some can be actually more than this. In this attribute table, you have what we call name, description, timestamp, begins, and altitude, so on and so forth. So I can decide to start putting that description. Maybe I know the name of the place, I will put it here. The timestamp, I'll put it here. The altitude, maybe the particular place I'm trying to point to, maybe is 100 and 500 meter above the sea level. I can put it there and so on. So that is how the attribute table looks like. So moving on to line. So this is an example of line. So if you look at this particular feature where this is a river, this imagery you are seeing down here, this particular imagery is a Google satellite imagery. It's a Google satellite imagery. We call it base map in GIS. So I just included the base map. So if you, I don't know if it's clear at your hand, but if you look very well, you discover that there is a river that is flowing here. That is flowing. There's a river. This is a river. This is a river. So what I did was I tried to digitize it using a linear feature, which is my line. So I was just trying to, digitize it. I'm trying to represent it instead of, the, what's it called? Instead of the satellite imagery. Once I'm able to represent it with line feature, through this like this, I can be able to calculate the length. I can be able to know that, okay, from so here to so place, the length of this river is so. I can be able to know, okay, it is other things I actually wants to know. So this is how road actually looks like. I mean, a linear feature. I can do the same thing with road. This is a road here. I can also try to, but I don't want to do that. I can just try to pick my, try to demonstrate. Let me see if I can even do that. Oh, sorry. Okay, wait, never mind. Let me just continue. So what I'm saying, I can decide to digitize. I can decide to digitize this road with my line poem, with my line shape. You know, how as long as I want, I can decide to use road to represent it and able to calculate the length and so on and so forth. And of course, I can also change the shape of the linear. It does not have to be in dots. I can decide to use another representation. I can decide to use another representation. Someone is asking, how can we install QGIS? By this time of the day, please go back to video one. Is it video one or course one? Sorry, module one. The video is there on how to watch, and you can also actually watch on YouTube. Please, the video is there. Go back to module one. It's there. So, okay, I'm trying to change the shape. So, I want to change the shape to, what shape can I change it to? I mean, okay, let me just use this one, this effect, I can say, yeah, QGIS gives you a lot of flexibility. If maybe what you are representing is a railway, you can use this. If what you are representing has to do with topo something, you can use this, various different markers that you can actually use. So let me use this and let me see how it looks like. You can see now that it has changed from that dot to something and so on and so forth. Okay. I think that's that about what's it called line. So let's look at polygon again. As I said, this is just a demonstration to tell you, to back up what I've been saying since morning. Okay, look at this. I said major road, right? See, I was also trying to do something with the major roads. You see, I didn't even have done something like that. I was trying to, digitize the major road, to represent the major road with a line feature. So this it looks like I can decide to increase the width of this major road. Let me try to increase the width. You see, I've increased the width. So as you can see now, so I can continue with it. Where is this place? Oh, so I can continue with it, and so on and so forth like that. So which other one again? Now, polygon. Remember I said polygon is what? Polygon has to close. And polygon is the connection of different lines. This is a line, 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 this is a line. They're all connected together, they're all close up together. That is what forms polygon. And I was saying something about node. This particular edge you are seeing here that took bend is a node. Over here is a node. This angle is a node, is a node. This is a node, this is a node, this is a node, this is a node, and so on and so forth like that. So these are polygon actually looks like. So let's assume maybe I want to demarcate all these whole place like this. I can do it. All I just need to do is just to demarcate it and close it, and that will give me polygon. So these are actually how they looks like. They come with different styles and so on and so forth like that. So what else again can I show you guys? We talked about the format, right? So for instance, remember I said vector always come with what? With SHP. So let me go and check the format of this boundary. Remember that boundary is polygon and the format. So what I should be seeing should be .shp. So let me check the information of this data. Now, I don't know if you guys can see it clearly, boldly. If you zoom in to this particular place, at the end of the day, you'll be seeing something like SHP. This is the name of it, boundary.shp. You can see that it's a shapefile. So this is a shapefile. You can see it's a shapefile, SVG shapefile. And there's a lot of information. Now, for some of you asking about the coordinate system, so if you check here like this, you already know, you can see coordinate reference system. Can see that this particular boundary, it is WGS84, geographical. It's in geographical, not projected. Take note of that. You can see it's in geographical coordinate system, WGS84. There are a lot of other informations. As you can see, this is attribute table. This is more like the attribute table. Let me go and check another one again. There's a lot of questions though. Sorry. Drop your question please drop your questions for this particular module, there are 2 videos. The second one has not been activated. Do you just joined? Please look through the link again. There's a link that has been provided for you to have access to it, so you can download it directly from the Google Drive if it's not playing. How can I generate Google Satellites link on QGIS? When we get to the practical section, I will be explaining that. To install QGIS, what other question? Okay, there's no any other question yet. So that is that. Let me check another one again. The one I just checked, let me check for point. For this point, let me check the information of this point. Okay, so this point, for instance, oh, I think I need to start rounding up now. So this part, you can see again, this one is still in SHP, and you can see again that this one is also in WGS 84. WGS 84. Now let me do something. I want to do something and see if it's going to work. I'm coming. Just hold on. I want to show you guys something. I really hope it's going to like clear my explanation. I'm coming. No, sorry. Yeah, I'm correct. Let me just save it as testing. Where can I save this? I'll just save it here. Testing point. Sorry, guys. I want to test something, and I really hope maybe it's going to explain something that I explained earlier. Okay, yeah. Okay, now let me change it to projected. Good. Okay. Good. Some to layout. So I'm trying to. I want to try to explain this projected and coordinate system. Oh, okay, I'm coming. Let me make use of this. Sorry, guys, I'm just trying to test something. No, let me export and bring it back in. Save as future. Testing 2. Save. I want to use this. Okay. Is that all? Okay. Okay. Sorry, guys, I'm still with you. I'm still with you guys. Oh, my camera is off. Okay. I really hope it works. I just want to show you the difference between projected and geographical coordinates. I just want to show you something. I hope you guys can still hear me because I think my camera just went off now. Oh, it's okay. This is what I'm looking for. I'm coming, guys. And the camera is off. Okay. Can I increase the width now? I mean, please, you guys should start. When we get to the practical section, this is something you'll be seeing or you'll be facing. Okay. Don't worry, it's not actually really showing me what I want. Okay, good. Now, guys, can you see my screen? This is what I actually want to achieve, and thank God I was able to achieve that. Guys, can you see my screen? I need to know if you guys can actually follow me,
We can
please.
see
I'm
it.
already rounding up already.
Yes, we can.
Okay, good. You can see my screen now. What are
You
you
can
seeing?
see-
You are seeing. I mean, someone should comment what you guys are seeing. Now, what I'm trying to explain to you is the difference between a projected coordinate and a geographic coordinate, that it is very important you knowing the right coordinates to use. What are you seeing? Now, what I did was that the real boundary, which actually originally came with actually originally came with geographical coordinates, WGS 84. I'm coming. Okay, I want to change the camera. Okay. Sorry, hold on. Is this it's just to get on. Is it showing now? Is it not small? Okay, not small. I think it's showing already. Yeah. So what I'm trying to say exactly is that now this red one you are seeing, that was the original data. Please, are you guys following? That was the original data, which actually comes with geographical coordinates. Remember that I showed you earlier. It comes with WGS 1984. Now, what I did was that I created another version using projected. So this black one you are actually now seeing is now projected coordinates. Now, immediately I did that. Do you see what happened? There was automatically a displacement. That was what I was trying to explain to you. I believe that this will actually now make sense to you like this. So what happens is that there is a shift, because normally this black one is supposed to be on top of this red one. It's supposed to be registering exactly on this red one, but immediately I switched the coordinates. Now these two are now in a separate coordinate system. One is running on a geographical coordinate system, and the other is actually running on a projected coordinate system. I don't know if that makes sense to you. Can you see the displacement that happened? So that shows that. So let's assume maybe this second one that I've actually brought in or actually changed to projected. Let's assume maybe it's a building or something that is very important like that. Can you see how displacement is going to happen? That is exactly how coordinate system works. And that's exactly why you need to know, verify, make sure you are using the right coordinate system. Does that make sense to you at all?
Yes.
Please, I need reply. Does that make sense?
Yes.
Yes.
Yes, it does.
Am I still audible? Okay, some people are saying yes. Okay, thank you very much for that. So that's just how it is. So I think what else again? Yeah, thank you very much. So I've explained the coordinate system just in brief. I've explained the special data. The what's it called? The database. There's actually nothing much to explain in database or to show in database. But just look at around here. This is a Joe package. If I try to open this, can I open this? I mean, this is how it actually looks, this is how it actually looks. Let's assume I have something saved in this. Then once I double click it, you're able to see all the files that I have in my Joe package, so on and so forth. It just gives you that organization, and that's all, guys. I think that's all. This class is actually, I think it should be over by now. So, guys, I think that actually comes to the end of module 2. Can you explain the part of this coordinate part again? Mr. So I didn't even know how to pronounce your name. Mr. Felix, I see you raising up your hand. Can you type your question, because if I allow you to unmute yourself, there might be some some distraction. So I think you should just type your question. So guys, your questions can start coming in the next 10 minutes, please, so that we can round up. You can start dropping your question concerning the course or any other thing. Can you explain the coordinates? What I'm saying about the coordinates is that these particular two lines you are seeing on your screen, this red and this black you are seeing, they are the same features, but different coordinates. So different coordinates, but the moment I use different coordinates, there was a displacement, there was a shift, and which is not supposed to be so. So it automatically tells us that any project we are doing or any layer we are bringing in, everything has to be on the same coordinate. It has to be on the same coordinate. Immediately I change the coordinate of that same feature to another coordinate, you can see that there is a displacement that happened, there is a shift that happened, which is not supposed to be so. That is the summary of coordinate. Thank you for the lecture. Does QGIS accept tabs5? What's tabs5? Tab5s. I don't know what that is. Are we to answer the module 2 assignment and submit? Yeah, please answer your assignment. The module 2 assignment, do it. Very on the group. I will share how you guys are going to submit it, or maybe you guys will go back to the LSM. Is it LSM or LMS? The learning system management. Maybe I will add it there, or maybe a link where you submit your assignment, the module 2 assignment. Maybe it will be sent to the group. Just do it on ground. A further instruction will be given onto you. Will be given to you. What other questions? Are we going to do module 2? Please let me check questions from that angle. Are we to answer module 2? Drop your. I'm not seeing that question here. When are we supposed to use geographical coordinate system? What's the right answer to answer that question? When what you are doing is pertaining to geographical coordinate system, when are we supposed to use a geographical coordinate system? I answer that question, sir, if you paid attention. If what you are doing is related to meter, if what you are doing, maybe you need to calculate an area in meter. If what you are doing, maybe you need to calculate in meter. In that kind of case, you cannot use geographical. You have to use a projected. That's number one answer. That you know that, you need to know the measurement of this in meter. In that kind of case, it cannot be in geographical. It has to be where? In projected. So if maybe what you are trying to do is in has to do with degree, just know that is geographical. You cannot use projected in that kind of case. So that's one scenario. And majorly, what I'm even trying to pass to you majorly is that make sure all your layers align. You can start your project. You can say that, for this project, I want to use projected. No problem. If that is what that analysis actually demands at that particular time. But make sure that any other layer you are bringing in also has to follow that projected or that particular, that particular coordinate you've actually used. Please, will the assignment be posted on the WhatsApp? You don't have access to the material. If you have access to the material, is always at the end of the the end slide of the is at the end slide of the PDF, and it has been pinned on the YouTube platform. The link to the Google Drive where you get both the videos and the videos and the PDF material that I just used now is actually in the link. That Google Drive link is there. So some of you are saying that, is this class recorded? Well, the class is recorded and the link will be shared. But if the link of the class is not shared, what I've explained since morning, since over 2 hours, is still the same thing that is inside that particular Google Drive, that particular video that is in the learning system management, or the link or the Google Drive that you get now. It's still the same thing. It's still the same thing. So either you have access to this recorded class that you're having now, or the material or the LSM is still the same content, the same thing I explained there. He said we should. Is the Google Drive in our mailbox? They just posted it again now. This is it. It's just been posted now. This is it here. How will I even pin it? Please look at the chat that you just typed and scroll down. You see the link there, please. You see the link there. The link was just posted now again by Integrated Area Acquisition. You should see something like that, both on YouTube. YouTube is even pinned. YouTube is even pinned. Where am I? Okay, I think I've answered all the questions from the Zoom. So let me check YouTube. For Cameroon, it is WGS 9084 Zone 32 North. Okay, thank you for that. What other things is here again? Which local? What we have local and global data. The WhatsApp link. The WhatsApp link is there now. Is it not pinned? Hold on. Please, admin, if you have the WhatsApp link again, please. People on the YouTube are asking. Who is this person asking? I need the course 1 link. Please go to your Gmail. Once your Gmail, a mail was already sent to you on your Gmail. I believe that everybody, there's not an exception, everybody already has a mail was sent to everybody. In that mail, you will see access to the LSM, Learning System Management. Please register through the learning system management. You have access to both the course 1, course 2, course 3, course 4, everything. You have access to it. So go back to your Gmail, your mail, look for the mail. You see something like maybe that Precision Field Academic as the heading, something like that. There is a link that will direct you to the learning system management. Please make use of that. That is where you have access to what you're asking for, sir. Please, we need the WhatsApp. They will post, they're going to paste the WhatsApp soon now. We are out of time. We are out of time, sir. Really? I'm the one that's supposed to be saying that we're out of time. No problem. I'm rounding up already. I think I've done enough. The red line and the black line. I don't know what you're saying. So once again, guys, as we are rounding up, please, once again, please, our Instagram page. Can you guys kindly just do me a favor before we round up? Kindly go to the page now as I'm speaking and kindly help us follow. Please do that now. Do that now. All the materials and the video going to be available after we are done with all the classes. I mean, after the course completion. Of course, now that LSM is free for you. Even after the whole 5-week class is complete, you still have access to go back to it and watch it. Thank you very much. Someone just said done. Please, if you know that you've actually followed us on IG and on YouTube, just put done. I want to see done. I just want to be seen done. Yeah, people with me here on Zoom are actually clicking on done. So people with me here on Zoom are actually saying done. So I also want to see people on YouTube. Please just click done if you know you followed us on IG and on Instagram, IG, YouTube. Please kindly do that, please. I want to see done. I don't want to be seen. Just put comment done. Just comment done. Okay, thank you very much. Thank you very much, guys. Thank you very much, guys. God bless you guys. YouTube, I'm still here to see you guys comment, please. Please, I expect the number should be going up by now. Subscribe, please. Before we call it a day, please kindly subscribe. Thank you for your nice presentation. Thank you for listening as well. So by either Sunday, the course 3 should be open. I think I already even activated by now, sir. But in case it's not activated, by Saturday or Sunday, the course 3 will be open. So please start learning course 3. Our next class again is next week, Friday, 5 p.m. to 7 p.m. Please, for some of you entering my team and asking that it should be the class is 7 p.m. before. The class has been shifted back to 5 p.m. considering the time zone of everybody. That is the best time that actually fit everybody, please. 5 p.m. to 7, not from 7 to 9, please. Take note of that. That is when we'll be having our next live class again. Thank you so much, guys. Yeah, thank you, okay. Don. I can see a lot of Don here, but I can't see people subscribing to our YouTube channel yet. Thank you very much, guys. So please, immediately the course 3 is open, you can start learning from course 3. Any additional information will be sent to the group. I believe the WhatsApp group has been posted on the group. Please, if you have any challenges on the WhatsApp group, kindly paste it there, show us your share the screenshots, I will attend to it, or other instructors on the group will actually attend to your questions and your challenges. Thank you. God bless you. Have a very nice day or have a very nice time. God bless you. Jesus is glorified. I think you can. Thank you, guys.